Hi, this is SN and welcome to my channel Concept of Mechanical Engineering. Here we are studying thermodynamics, and in thermodynamics we have completed chapter 1. In previous class we were doing the numericals on basics of thermodynamics. Today also we will continue the same. The question is, the reading TA and TB of two thermometers A and B agree at ice point 0 degree centigrade and steam point 100 degree centigrade and are related by the equation TA equal to L plus mTB plus NTB square, where L, M, N are constants. When both are immersed in oil, A reads 51 degree centigrade and B reads 50 degree centigrade. Determine the reading on A when B reads 25 degree centigrade. Discuss the question which thermometer is correct. So we are going to solve this one. What is given in question? We have given TA equal to L plus mTB plus NTB square, and also it is given that TA and TB, both the thermometers agree at ice point which is 0 degree centigrade and steam point which is 100 degree centigrade. So at 0 degree centigrade the value of TA and TB will be same. So at ice point, TA we have 0, L plus M, TB is also 0 because both agrees at ice point. So we have N into TB equal to, TB is 0, so solving this L equals to 0. We will consider this as equation 1. At steam point, in question it is given that at steam point both TA and TB agrees. So at steam point TA will be 100 and TB also will be 100. So 100 TA, and place of TA we can put 100, L plus M into 100 plus N into 100 square. Putting the value of L equals to 0 in equation 1, we get 100 equals to 0 plus M into 100 plus N into 10 to the power 4. Dividing both sides with 100, we get 1 equals to M plus 100N. This we will name it as equation 2. At when both are immersed in oil, A reads 51 degree centigrade and B reads 50 degree centigrade. So in case of oil, A is 51, so temperature is of A is 51 and B is 50 degree. So L plus M into 50 plus N into 50 square. From this, putting the value of L from here to there, we will get L as 0. So 51 equals to 50 M plus 2500 N. This we will consider as equation 3. Now multiplying equation 2 with 50, we get 2 multiplying with 50, we will get 50 equal to M plus 100. This is 50 equal to 50 M plus 5000 N. This is equation 4. Now subtracting equation 4 from 3, we get equation 3 minus 4. So equation 3 minus 4, this is equation 3 and this is equation 4. If we subtract from equation 3 we subtract equation 4, we get this minus 51 minus 50, that is 1. 50 will cancel out, 0 plus 2500 minus 5000, this is minus 2500 N. So from there we get 1 equal to minus 2500 n. So solving this, n equals to minus 1 by 2500 is equal to minus 4 into 10 to power minus 4. Putting this value of n from here to equation 2, we get, that is equation 2 is 1 equals to m plus 100 n. So this is equation 2. Putting this value into, we get 1 equals to m minus 100 into 4 into 10 to power minus 4. From there we get 1 equals to m minus 4 into 10 to power minus 2. This is 1 equal to m minus 0.04. From there m equals to 1.04. So we have got the value L equals to 0, m equals to 1.04 and n equals to minus 4 into 10 to power minus 4. So putting these values in equation, this TA equals to L plus mTB plus NTB square, we get TA equals to 0 plus 1.04 m plus minus 4 into 10 to power minus 4 into TB square. Sorry, here it is TB 1 and the value of m is 1.04, so it is TB. That is TA equals to 0 plus 1.04 TB minus 4 into 10 to power minus 4 TB square. And it is asked in question the value of TA when TB equals to 25 degrees centigrade. So at TB equals to 25 degrees centigrade, we have TA equals to 0 plus 1.04 into 25 minus 4 into 10 to power minus 4 25 square. By solving we get TA equals to this, we have 0 plus 26 minus this, we have 0.25. So TA equals to 25.75. That is, when TB is 25 degrees centigrade, then A reads 25.7 degrees centigrade. So the first part of the question is solved, which was asked that determine the reading on A when B reads 25 degrees centigrade. So when B reads 25 degrees centigrade, the value of A is 25.75 degrees centigrade. The next part of the question is which thermometer is correct. Discuss the question which thermometer is correct. So from there it is impossible to say that is impossible to conclude that which thermometer is correct. If one is correct, other has to be wrong. So it is impossible to conclude that which thermometer is correct. It is impossible to conclude which thermometer is correct. If one is correct, other has to be wrong. So it is impossible to conclude which thermometer is correct, and if one is correct, other has to be wrong. So we have completed this chapter. In next class we will start the next chapter of thermodynamics. Before concluding this chapter, we will discuss one question. This type of question is asked in ESE examinations, assessing and reason question type. So let's see one question. Statement 1. If alcohol and mercury thermometer reads exactly at ice point and steam point, then these two thermometers will give exactly same readings at 50 degrees centigrade. And the reason is temperature scales are arbitrary. The options are: first option, both statement 1 and statement 2 are individually true and statement 2 is the correct explanation of statement 1. Both statement 1 and statement 2 are individually true, but statement 2 is not the correct explanation of statement 1. Statement 1 is true, but statement 2 is false. Statement 1 is false, but statement 2 is correct. So this is a question. The statement 1 is given: if alcohol and mercury thermometer reads exactly at ice point and steam point, then these two thermometers will give exactly the same readings at 50 degrees centigrade. In the previous question we have seen that there were two thermometers, both agrees at 2 points, but the reading at third points were different. So we cannot say that if the two thermometers agrees at 2 points, at ice point and steam point, then these two thermometers will give exactly the same reading at 50 degrees centigrade. So this statement is false. And we know that temperature scales are arbitrary. We have seen this in the previous classes, that temperature scales are arbitrary. In the question also we have shown that we have constructed our own scale, P scale. So temperature scales are arbitrary. So this statement is true and statement 1 is false. So statement 1 is false, but statement 2 is correct. So D is the correct option. So answer is option D. We have concluded the first chapter. So we will start next chapter in next class. Thank you.